Hello, this is the second video in looking at section 3.4 from the law textbook. So we're doing a bootstrap confidence intervals in chapter 3. And I want to talk about in this video some cautions using this bootstrap approach. These methods, they only work if the bootstrap distribution, so this would be the sampling bootstrap distribution, is smooth and symmetric. So we always want to look at a plot of the bootstrap distribution before we do compute the actual bootstrap confidence interval. Because if the bootstrap distribution is highly skewed or looks spiky and there's gaps, then we need to go beyond intro stat to create a confidence interval. And we'll look at other techniques when we move to chapters 5 and 6. So let's take an example. Here we've got body temperatures. We looked at this before, but now we're looking at median instead of the mean. Earlier in the previous video in the slides, we looked at mean. Now we're looking at median. So we have still the same original sample with the mean of 98.26. But notice in the bootstrap distribution, there's 1,000 bootstrap samples here. This is not symmetric and smooth. For one thing, there's definitely a little bit of a right tail, a right skewness to this distribution because of these plots right here. And notice the center of this distribution in terms of the highest value is off a little bit from the median. So the mean and median are off a bit, so this is not symmetric and this is not smooth. So we would not want to use this for confidence intervals. One other thing to talk about is the number of bootstrap samples. If we're using this bootstrap technique, you're going to get slightly different confidence intervals each time, and that's okay. So there should be a tolerance set up for your online homework to accept a range of values for these confidence intervals. And as I said before, we're going to move to more a classic standard approach to confidence intervals in chapters 5 and 6. And that's the case everyone's going to have the same exact answer. But this bootstrapping brings in that variability of how they compute the random bootstrap samples. So there's going to be some difference. Generally, the more bootstrap samples you use, the more precise your answer will be. Since it's fairly easy to do in StatKey, I'm going to say for homework, exams, and whatnot, always go to at least 2,000 bootstrap samples. But if you want to be more accurate, you could do more, since it's not too difficult and time-consuming to do in StatKey. So make sure to do at least 2,000 samples. All right, as a summary from chapter 3.4, we looked at 95% confidence intervals. Can be done using the standard error, which we did in section 3.3, or the percentile approach, which is new in this section. If we want to pick any other desired level of confidence, the two most standard are 90% and 95%, then we have to use this percentile method. And a confidence interval from bootstrap percentiles can be created for any parameter. But here's the warning, don't forget that bootstrap distribution has to be approximately smooth and symmetrical. Thank you.